choices for setting up the integral for this problem. You can use either the washer method, in which the typical washer is perpendicular to the axis of revolution, and that's represented by this typical washer right here, perpendicular to the axis of revolution. So you're going to have infinitely many of these washers. And so the outer radius squared is the distance from the axis of revolution out to this point right here. But that has to be, that's an x distance, a horizontal distance. So it has to be solved for, we have to solve for x in terms of y. So since this is the line y equals x equals y is the outer radius, or y is the outer radius, or x is the outer radius. But for this distance right here, the inner radius, that's going to be, since y equals 7x, then the horizontal distance is x equals 1/7 y. So that's what's depicted in this integral right here, where I'm using outer radius squared minus inner radius squared. I'm integrating from 0 to 21 along the y-axis. Outer radius is y squared, and the inner radius is 1/7 of y, 1/7 y, the quantity squared. And I'm integrating with respect to y, so dy. So now, just so you can see the difference, I've also set it up so that we're using the shell method, which means our typical shells are parallel to the axis of revolution. And this distance is the average radius, and the height of the shell is top minus bottom. But that formula is going to be different from along the x-axis from 0 to 3, and then from 3 to 21. So here we're going from 0 to 3. The typical or average radius is represented by x, and the height of the shell is, and I could have simplified this, but for emphasis, it's top 7x minus bottom x. That's the height of a typical shell in the interval from 0 to 3. But then when I get to the right of between 3 and 21, the height of this shell is always 21 minus x. Because this is the line y equals x, which is why that's the case. So this is the this is 21. This distance is x, well, because y equals x, and I have to subtract that to get the height of this green segment. So there's your two possibilities for solving this problem. Obviously, the washer method is a little more convenient to use, but it's also, you have to understand how you have to solve for x in terms of y, and then integrate with respect to y. And I'm going to share my screen. And here is where I copied this picture from Desmos. And there's how I set up the region right there. So you can expand these to see how I created the region, how I created the typical shells, how I created the typical washers. Okay, so I'm going to save this URL, or copy this URL to the answer also. End of recording.